Good morning, everyone, or good afternoon, wherever you're tuning in from. Welcome to today's Stakeholder workshop on marine mammal monitoring and innovation, brought to you through a partnership between the IMarEST, which is the Institute of Marine Engineering, Science and Technology, and its Marine Mammal Special Interest Group, and the Defra Marine Natural Capital Ecosystem Assessment Programme. We're also pleased to have endorsement today for the UN Ocean Decade for today's event. My name is Neil Dorian. I'm the co-team lead for this project. I'm joined today by my fellow team lead and co-chair Liz Ferguson, as well as our dedicated team, who will introduce shortly. To start with, I'd like to give you a brief overview of today's agenda and provide some useful information. Following this, we'll have an introduction from our colleagues at Defra, who will share further context on their wider project and objectives, and then provide you with a summary of some of our survey results and horizon scanning. And thank you all today for joining us, and I look forward to some insightful discussions ahead. So just to run through our agenda for today, we've got quite a packed agenda. We'll be taking a 25-minute project introduction, and then we'll move to our first session between 13:25 and 14:10. We'll then be followed by a quick 10-minute break, and then we'll go through our first session. We'll followed by a second break, and then a further workshop breakout rooms. Just a couple of important information. Today's event is being recorded and all participants will be notified on the recording once available. Breakout rooms will be recorded for note-taking purposes only and will not be included in the workshop recording that will be made available. If time permits, we'll address specific questions from our speakers. However, as time is limited, discussions will primarily take place during the breakout rooms. So just a little bit of background and information on our project. So we're at the IMarEST Marine Mammal Special Interest Group, and our partnership is through Defra. They're specifically the Marine Natural Capital and Ecosystem Assessment Programme. The primary objectives here for our project are to evaluate the current state of marine mammal monitoring methodologies and technologies, identify gaps in existing monitoring practices and opportunities for innovation, and to conduct a horizon scan to explore emerging trends, tools and advancements in marine mammal monitoring. And we've done this through conducting engagement with industry stakeholders and today's event. To introduce our team, my name's Neil Dorian. I'm joined with my fellow co-team lead, Liz Ferguson, our IMarEST support team, Peter Shepherd, Head of Technical and Policy at the IMarEST. Also Ashley Noseworthy, Lorenzo Scala, Dr. Andrew Wright, and Ashley Kitchener. So just a little bit of background with regards to the IMarEST. We're an international professional body and charity for professionals. We represent over 120 countries with over 50 branches, and we were founded back in 1889. We're the largest institute of its kind, uniting over 12,500 marine engineers, scientists and technologists. We promote marine engineering, science and technology, and foster knowledge and exchange and professional standards. We also hold special consultative status with the UK ECOSOC, as well as consultative status with the IMO. Our Marine Mammal Special Interest Group was founded in 2020. It's one of the IMarEST most active groups dedicated to advancing marine mammal science and conservation. We've got over 400 members. We deliver a range of initiatives, including webinars, workshops, science communication articles. We've produced a career matrix for graduates as well as employers. We also provide university guest lecturing. And our work extends to contributing to mainstream news outlets, comments and articles, and supporting the UN Ocean Decade and sustainability goals through a variety of organised activities that which we seek endorsement for. We're also proud to partner with Defra on this programme today, and specifically the wider Marine Mammal Monitoring Innovation Project, which it was established at the end of last year and will run through until March, middle of March next month. And we aim to drive forward research and solutions for marine mammal monitoring through this. So just with that in mind, I'd like to hand over to our colleagues at Defra, to Liam, who will do a bit of an overview with regards to the background of the project and the work that Defra are undertaking in this space. Hand over to Liam. Thank you very much, Liam.
Brilliant, thank you. Can you hear me okay?
Loud and clear.
Excellent stuff. So good afternoon, everyone, and thank you very much for taking the time to join today's workshop. It's an absolute pleasure to see you all. For anyone that isn't aware, I'd like to take some time just to share the background about the Marine Natural Capital Ecosystem Assessment Programme, talk through some of the drivers behind this work, and outline why this study and some of your insights from today are absolutely essential to helping inform government ambition and also shaping our future policy and decision-making processes. So the Natural Capital Ecosystem Assessment Program is Defra's flagship R&D program. It's been running for 3 years now. We're currently in the final year with the program closing in March 2025. And the marine component of this program is leading the way in which government enables its ambitions to better account for the value of nature and help integrate natural capital into our policy and decision-making moving forwards. By providing a strong evidence base and associated suites of tools through this program, we are transforming the way in which we understand, protect, and ultimately enhance the condition of our marine environment. Our oceans are facing very complex and interconnected challenges, which is why the Marine Natural Capital Ecosystem Assessment Program is taking the step towards holistic approaches, helping to bring together that environmental, economic, and social data to better understand those relationships, impacts, and trade-offs between drivers of change, both natural and anthropogenic, and how marine biodiversity responds, ultimately to inform some of our conservation measures and interventions. Now, we understand the importance of technology and innovation in collecting high-quality data to help inform this effort, which is why through the program we're driving towards innovation, particularly innovating the marine monitoring and sampling technologies that we use. We have invested so far around 2 million in collaboration with Innovate UK to help support R&D in this space alongside the testing of emergent technologies for data collection and analysis with the vision to improve our future monitoring systems. We're working towards that system that can give us that better spatiotemporal data. Ultimately, it's to improve our understanding of environmental condition and also help reduce some of the monitoring costs and alongside the wider carbon intensity of our monitoring activities. This drive towards innovation will help improve our ability to meet statutory monitoring obligations, as well as a variety of cross-departmental and governmental priorities. And this could include, but is not limited to, good environmental status, net zero, and biodiversity net gain. Now, as the Natural Capital Ecosystem Assessment Program comes to a close in March 2025, we're working to position Defra so we can target departmental innovation and investment towards the highest priority areas, and this includes marine mammal monitoring. We want to ensure that our innovation portfolio is delivering targeted investment, which addresses key gaps and evidence needs in marine mammal monitoring technologies, and also seizes and capitalizes on those opportunities to better meet current and emergent policy requirements. This is why we're working with IMarEST to undertake a study to identify opportunities for innovation and help shape some of that planning and investment for future marine mammal monitoring. Throughout the study, we're assessing the current state of marine mammal monitoring, how we're approaching this, including a targeted literature review alongside stakeholder engagement to evaluate existing methods, as well as exploring their limitations and gaps and helping to mitigate these moving forwards. So this study features as a global horizon scan for innovation opportunities, looking into the emergent technologies, including AI, eDNA, marine autonomous monitoring schemes alongside those. And this study has already received significant input from a diversity of marine stakeholders, with wide-ranging technologies and monitoring approaches represented in our stakeholder survey and throughout the submissions to this event. Some of the outcomes of this study will help strengthen the understanding of emerging innovations in the marine mammal monitoring sector and will help inform Defra with valuable recommendations on how these technologies can better align to address existing gaps and monitoring evidence needs. And furthermore, the study will support future decision-making and ensure that our innovation commitments are actually supported by research and key stakeholders in this space. Now, turning to today's workshop, we see it as an essential study to engage with an existing network of experts from industry and academia. But ultimately, this is an opportunity to contribute to the study by voicing your views on the technologies and data gaps that you think need addressing, and what innovations can help us achieve that, and how we can best support these areas. We're very keen to learn about your specific technologies and your expertise, the sorts of methods you're using and innovation that already exist, and how we can then capture that information to drive forwards our ambitions in this space. So your insights and expertise are invaluable in improving our understanding, and we look forward to hearing about your contributions and discussions. With that final note, I'll pass back to our chairs to begin the workshop. Thank you.
Thanks very much, Liam. That was great. Thank you so much. We're just going to now take a few minutes to go through our survey responses. And I'm just going to hand over to Andrew Wright, and then follow up with Ashley Noseworthy, who will run through our horizon scanning. Andrew, please feel free to go ahead.
Hi, everyone. Just give me a second to share my slides. Excellent. Okay, well, thank you very much for listening today. I'm going to talk about the stakeholder survey that we ran in January. It was 46 questions, mostly multiple choice. And it was open for 16 days over the course of the middle of January. And despite the fact it was just back from Christmas, we had 133 respondents, although not everyone answered every question. So who were those respondents? Well, most of them were based in the US or the UK. The third option was Canada. And they operated around the world, but specifically, we're looking here at the UK and the North Sea. And those that selected that they operated globally was also 20%. So about a third of the people were housed in the UK and about a third operate in the UK. Neither of those operating options were mutually exclusive. Now, most of the respondents use acoustic data, although visual and biologging data were secondary for that. And people seem to collect their acoustic data using instrument packages, primarily surface platforms, but subsurface platforms and other aerial platforms also got a mention in the type of platforms that were used to collect this data. Commercial software packages and custom scripts were the primary choice for analyzing the data, although human in the loop and fully AI options were also put forward. And the uses for all this data and effort was quite varied. However, the primary use for all of this data was for assessment purposes. Now, in terms of the considerations, what people relied on, what people took into account when they were putting their plans for monitoring together and selecting their equipment and data. The primary objectives and regulatory requirements for the area that the operation was in and the project itself, but also the potential impact on the animals and the environment were considerations that were taken on board. These were the primary four there. Data quality assurance and validation processes were also high in consideration, as was the reliability of species detection or classification tools. So it's clear people thought about whether or not they could pull out the species of interest, whether they're using acoustics or visual or whatever. So then we started in the survey moving from what you were doing to what you would like to do or what you think the future will look like. And Ashley will go into a little bit more detail about some of this shortly. But in terms of what's underutilized currently, despite the fact pretty much everyone was using PAM, it was still deemed to be underutilized. Multi-sensor platforms, so that would be PAM and visual, for example, was another area which was considered underutilized, as was artificial intelligence. Other machine learning applications were also considered underutilized at the current time. And things that were required improvement before they could contribute more extensively to marine mammal monitoring at the current time. Software development is required, as is species identification capabilities, localization and tracking, and power capabilities, battery life, and detection rates were also considered in need of further improvement. And for detection rates, that's considering how marine mammal presence and behavior might impact detection rates over time. Now, as I said, Ashley will go into this in a little more detail, but just the 30,000 feet option. When talking about technology for the future, not current technologies for improving, but what was going to be developed in greater leaps in the upcoming short or near term. AI is a clear favorite from the respondents. Again, acoustic detection methods features heavily, satellite detection, aerial detection, AUVs, but also thermal methods and DAS. In terms of what these improvements, what the gains were from these improvements, what they granted, spatiotemporal coverage was a large consideration, better understanding the species to get at that detection rate related to the improved detection of the animals. Quicker, accurate detection and classification. Reduced cost was a big one. And there were a few other items there, and then another half a dozen options that are not presented here. So clearly everyone believes the future is AI, so we have to accept Skynet is coming. But the other things that were noted as being in the future was a need for better understanding of species behavior and improved detection rates and accuracy. Now, I note here that the support for tagging technology was low, despite the fact that's likely how we're going to get at that first point. Few respondents used text to gain data on marine mammal health or human impacts, but both were moderately supported for the future. So that's one thing to consider, sorry. And I've rearranged bullet points because I wanted to end on the fact that PAM, satellite detection, DAS, thermal methods, all identified as important. But considering all of these conclusions, you have to remember that a good chunk of the respondents were currently using passive acoustic monitoring. So you have to take that with a little pinch of salt, and that affects all three of these bullets. Not just a selection of PAM as a top thing for the future, but also the sort of more moderate placement of other technologies at the bottom there. So that's the survey in a nutshell, and I will now hand over to Ashley to go into the future tech and the horizon scan in a little bit more detail.
Thank you, Andrew, and welcome everybody. Before I get into the horizon scan, I'll let you digest what Andrew's put on the table, and you'll also see on the side of your screen that we have started to ask a few questions via an app called Slido. I can see that there are a few people that have already participated in the Slido questions, and so we're just going to take a moment, and if you'd like to kind of think about what Andrew said, but then also participate in Slido, that would be great before we move on. So we can see that there are a number of different countries represented here on the call. We do have almost 150 people here with us. So the UK, Canada, the US, Portugal, the United States, Saudi Arabia, Germany, Brazil. I apologize if I didn't mention your country, but you can take a look at that and add a response. So it's great to see so many different countries represented on the call, and thank you for joining us. We do have a few more questions to ask as well. And so I'll get you to, I think, Paige, can you move to the next question or launch the next question? Perfect. So the next question is, what sector do you work in? And we've given you a few options here. So academia, government, private industry, NGO, not-for-profit. Just take a moment and pop that in. We can see private industry is represented, academia, NGO, research, multiple, consulting, students. That's great. It makes for a well-rounded workshop when we have lots of representation. So thank you. I can see a few questions in the chat related to how to participate in the Slido. And I will let IMarEST, I will let Paige, who is a bit of our guru in Slido, answer those questions in the chat. So we should have some answers for you in there. As we continue through, if you don't get a chance to participate in Slido, there will be a chance to potentially introduce yourself if you didn't get a chance when we get into the breakout rooms. So please don't feel discluded. You'll have the chance to share that if you'd like once we get into some of the other parts of the workshop. Moving on, we do have one more question. I'll let Paige, flip that over. There we go. What areas of marine mammal monitoring do you specialize in? And I know that there might be a variety, so feel free to put in a few options here. There we go. And there was a link that was just put in the chat. If you can't access it via Zoom, there is an external app that you can go to and a link in order to participate. So feel free to click on that in the chat. Okay, so we can see at the center, visual monitoring seems to be highly represented. PAM as well. We have eDNA, we have impact assessment, UAVs, AI, data analysis and cloud solutions. Okay, this is great. We were hoping for a multidisciplinary group of people. So that's wonderful. It'll make for some great discussion a little bit later. Visual monitoring, seal photo ID. That's excellent. Okay, that's great. Thank you for participating, everybody. It gives everybody a little bit of context of who's on the call, and where we can go and kind of where everybody's from. From here, I am going to pick it up where Andrew left off, share my screen and discuss the horizon scan with you, and then we're going to get into it. So just give me 1 second. There we go. And you should be able to see my screen. Okay, let's discuss the horizon scan. So there's a little bit of overlap with the survey. Essentially, a horizon scan, we wanted to involve that systematic process to look at the changes and thoughts of people of what's coming in terms of technology and identifying those trends that are coming in the future. And so survey respondents were asked about those types of technologies that they think would be really critical in advancing marine mammal monitoring over the near and long term. And they were also asked about how critical they think those advancements would be in the time frame. And I'll define near term and long term in the upcoming slides. And in regards to the context of this and the makeup of respondents, you have to consider that. And Andrew touched on that just briefly. But for example, when we did the survey and then we incorporated those results in the horizon scan, it was heavily skewed for personnel that I identified that they worked in acoustics, whereas we only had 2 respondents that were coming from a pathology veterinary background that provided data and input. And so obviously we can't control for that, but it's important to keep that in the context of the results. And I also wanted to point out that the workshop is also going to feed into the final results of the horizon scan. So the things that are not only presented here today, but the discussions that are had in the breakout room will feed into a lot of the information and some of the deliverables for the horizon scan in the final report. We also looked at adjacent disciplines for monitoring technology, specifically terrestrial companies and terrestrial biodiversity monitoring. What are the technologies and tools that they're using? And is there overlap, which there was, but are there also opportunities for collaboration and what can be learned in regards to those? So when it came to the emerging technologies, and there was a slide similar that Andrew put up for this. So just to kind of define, near term is kind of 1 to 5, long term is 3 to 10. And over that near term, so people who responded, there was about 89 respondents. Many of those expected critical developments in things like acoustic solution methods, aerial detection methodology, autonomous underwater vehicles, AI methods, and thermal methods. So you can see that there on the top. And most of those developments are expected over that near-term time frame, although there was some people that responded in our research that perhaps indicated that there could be a breakthrough in acoustic detection methods over the next year or so, potentially with the integration of AI. And over the longer term, providing a wider range of potential technologies where there could be critical developments might occur, although those overlapped with what reported in the near term. So you can see that overlap on the graph. And there was less agreement in long-term developments than near-term ones. And some of those respondents spread their expectations across a wider range chronologically between the 1 to 10 years. And ultimately, in the long-term developments, the responses that we received, some of the more interesting inclusions that are perhaps not categorized here are things like the Internet of Things, lithium battery alternatives, integrated detection technologies and platforms, and even the potential rise of an unknown detection method. When it comes to the expected benefits of critical developments, so when queried through our own search and through the respondents in the survey in the context of the Horizon Scan on what benefits technologies might provide, quicker and more accurate detection and classification, and increased spatiotemporal coverage were seen as the most likely benefits. And so you can see here method and development on the left and area improvement of the right. We took those responses and what we found in our own Horizon scanning and then looked at how that fed into areas of potential improvement. There was also the long-term need filled by those emerging technologies and where those are going to fit into those areas of improvement. And so over the longer term, that increased spatiotemporal coverage was the key benefit that was pulled out, with the reduction of costs of monitoring coming in a close second. Operational efficiency and integrity was a highlight in our Horizon scanning, and that related to the spatiotemporal coverage for increased comprehensive monitoring. The cost effectiveness also came into play, and so how can we increase spatiotemporal coverage while also balancing the cost-effective operations? And that seemed to always be in the context of the utilization of unmanned systems and their remote deployment. And again, we did look at the terrestrial. And just to give you context, we looked at 39 different companies developing wildlife monitoring technologies. A lot of those did exist and do exist for marine mammal monitoring already. However, there seems to be broad applicability across various wildlife species, birds, bats, large terrestrial mammals. And so the technologies like satellite tracking and drone surveillance, all of those are widely used, but could continue to evolve in things like automation and miniaturization and integration through collaboration with those sectors. Finally, I'll cap off with benefits and implementation strategies. And so the tailored benefits ultimately from the Horizon Scan thus far would be speed, accuracy, the species behavior insights, and health assessments for marine mammals. Industry collaboration to scale and adaptation of wildlife monitoring tools also came into play. And so it's the collaboration piece really came out in some of the Horizon scanning. It was also mentioned policy engagement. And so I will put forth that in the final report, we are keeping in context, and we've highlighted some countries' regulations and legislation in relation to marine mammal monitoring and what that looks like, because it's one thing to talk about the technologies and what might emerge, but is that in line and what's happening with current regulation and legislation? So I will cap it there. It's lots of interesting results and pass it back to Neeru.
Thank you for that, Ashley. I'm going to pass to my fellow co-team lead, Liz, for the next section of this to introduce our wonderful presenters. Thanks very much, Liz.
Yes, thank you. And I just want to mention too that we are going to get into the presentation section for session 1 and session 2. We have 2 parts and a break in between. And before we start with our first presenter, I want to mention that we hopefully will have a little bit of time for a couple questions towards the end of this first part. So if you do have any questions as you're listening to any of the presenters, there's a Q&A button along the bottom that you can go ahead and throw those questions into, or you can just hold those questions to the end of our set of presenters now, and then we'll get to that and be able to address as many as we have time for. So with that, we've got a few video presentations as well as live presentations. I'll go ahead. We've got several video presentations in this first session, first part. We're getting started with Nathan Giraldi from Nature Metrics, and I'll go ahead and let Paige share her screen for that video presentation.
Hi, everyone. I'm Nathan Giraldi, lead marine scientist at Nature Metrics. I have over 2 decades of experience in marine ecology and biodiversity monitoring, and the technology I will talk about will change the way we assess marine communities more than anything else I'm aware of. I'm going to share how we're enhancing marine mammal monitoring through using environmental DNA, or eDNA. In NatureMetrics, we're dedicated to making biodiversity measurable at scale, and today I'll show you how we monitor marine mammals using eDNA through real-world applications. NatureMetrics is a global leader in biodiversity monitoring, recognized for our innovative approaches to measuring nature at scale. Our achievements include winning the 2024 Bloomberg NEF Pioneers Award, receiving Google's Geo for Good Impact Award, and being nominated for the prestigious Earthshot Prize. In addition, these are just a few of the over 500 clients we have worked with in over 100 countries. These accolades reflect our commitment to developing practical solutions for biodiversity measurement. eDNA offers a simple yet powerful approach to marine mammal monitoring. All living things leave traces of DNA in their environment. We collect this eDNA by collecting water samples, which is as simple as filtering water, which anyone can do. Filters are then sent back to our lab. The DNA is extracted from the filters and amplified. The DNA is then sequenced and matched with reference sequences to identify the animals from their eDNA. We can detect many species simultaneously without the need for direct observation. This method works effectively even in poor visibility conditions and is less constrained by environmental conditions and safety issues compared to other survey methods. What makes this particularly valuable is that a single water sample can reveal the presence of many species, providing a comprehensive picture of marine animal diversity in the area. This is especially crucial for environmental impact assessments and long-term monitoring programs. Let me share some exciting real-world applications. We've successfully implemented eDNA monitoring across various marine contexts, from nearshore to offshore environments. One particular innovative application involves our partnership with the MSC Foundation and MSC Cruises. In this project, we detected 29 different cetacean species and identified 17 IUCN Red List species from only 18 samples. But perhaps most exciting is that we worked with them so that samples could be collected by anyone and did not affect their operations at all. We're also working in partnership with sailboat racing events and offshore wind farm developers using eDNA to inform environmental impact assessments. This technology helps identify seasonal patterns in marine mammal presence. In the case of the offshore wind farms, this will allow operations like pile driving to be scheduled during periods of minimal impact. Finally, we partnered with Sussex University to monitor kelp recovery efforts, and this study found that eDNA was more effective and less expensive per species detected than video-based surveys. The practical benefits of this approach are substantial. By providing reliable species detection data while reducing operational complexity, we improve marine mammal monitoring programs. This technology is particularly valuable for infrastructure projects where understanding marine mammal presence is crucial for compliance and environmental protection. In conclusion, eDNA-based monitoring is proving to be an invaluable tool that complements existing marine mammal survey methods. It offers enhanced data quality and cost efficiency. Through partnerships with cruise lines, offshore energy companies, and conservation organizations, we're demonstrating how this technology can scale to meet global marine mammal monitoring needs. Thank you for your attention and look forward to any questions.
All right, and I know that looks like Nathan is in our crowd today, so thank you very much for that presentation, Nathan. That was fabulous. I'm going to keep moving on, though, and we'll have a video from Jamie McCauley, also of University of St. Andrews.
Hi everyone, my name's Jamie McCauley. I'm a research fellow at the Mammal Research Unit within the University of St. Andrews. Today I'm going to talk about how we use passive acoustic monitoring to look at the density and behaviour of dolphins and porpoises around static fishing nets. And just a shout out to all my co-authors, this work would not have been possible without them. So static fishing nets, for example gill nets, are by far the largest cause of anthropogenic mortality in small cetaceans. And to understand why animals become entangled, we wanted to ask two questions. And that was, what is the density of porpoises and dolphins around nets, and does that relate to bycatch risk? And the second question was, what is the fine-scale movement behaviour and acoustic behavior of these animals around nets, with an eye to understanding how dolphins and porpoises with highly sophisticated biosonars, we know they can detect nets. How do they become entangled in these nets and ultimately bycaught? So for the first question, we deployed sound traps, which are single channel high frequency recorders. And they are great because they're the size of a Coke can, they don't interfere with fishing operations, and we use our fisheries observers to deploy them on nets. So when you get your sound trap back, you can pass it through some software and then look at the overall soundscape along with the target species of interest. So in the top plot here, we have a long-term spectral average. And within that, you can see dolphin clicks and whistles. There's a large porpoise detection. There's even military sonar there. And then we use specific algorithms to find our target species of interest. The bottom graph here shows the number of porpoise clicks per unit time. So the sound traps provide really nice contextualized data, but we have 153 days of recordings across 146 deployments now, which is a relatively large data set, and that requires automated analysis. So we are using the sort of latest AI algorithms integrated into PalmGuard software, along with some more traditional sort of signal processing and heuristic algorithms to pick out the target signs of interest. And ultimately, what we're going to end up with is an idea of the density of porpoises and dolphins around nets, across seasons, across different sites, and that's going to provide us with a wealth of information to inform mitigation strategies. So the second question is looking at the fine-scale movement behavior around nets and cross-referencing that with acoustic behavior, sort of telltale foraging events, for example. And the way that we did this was we created a device that has 4 closely spaced hydrophones in a sort of tetrahedral configuration and a really nice orientation sensor. We put that on the headline of the net, and each of the devices is capable of determining a bearing to a click produced by a dolphin or a porpoise, for example. And if both devices detect the same click, then where the bearings cross is the location of the animal. Because the animals click consistently, then we are able to reconstruct a track of an animal around a net. And this is what the devices look like. The one that we're using to determine density is at the bottom there, and then we have a slightly larger device which is capable of localizing the position of animals. And even the larger device is fairly okay to stick out on boats. It doesn't really interfere that much with fishing operations, although it does require probably a dedicated researcher usually to go out and sort it all out. And the results that we get from the 3D tracking algorithms are really interesting. Here's an example of a porpoise that looks like it's approaching the net, but actually stays away from it. So it sort of approaches the net, but then it goes shallower, so it's never really within the danger zone of a gill net. And we have now dozens of these sort of events showing porpoise behavior around nets. Some of them come close, some of them stay away. And the really interesting thing that we can do is we can cross-reference the tracks with acoustic behavior. So the diamonds on that plot are foraging buzzes. So we're carrying on this project at the moment. It's being funded by Sabrina, which is a big EU project looking at bycatch. And what we're going to do over the next few years is collect a huge data set on behavior around nets and density. And we hope that will inform mitigation and conservation measures for fisheries. Thanks very much for listening, and thanks to all those that have been involved in this project.
All right, and thank you again, Jamie. I know you're online. Thank you so much for that as well. I'm going to keep moving us along, and next we'll be hearing from Rob Lee from SAISH, and Rob is going to be our first live presenter during this session. So I'll let you go ahead and share your screen.
Okay, can you see this? Let me see the screen.
Yes, we can. Thank you
Yes.
so much. Perfect.
Okay, so what I'm going to do is give a real quick whistle-top tour of advancements in marine autonomy with specific attention to remote and real-time data collection. So we live in a world where we expect everything now, and marine survey is no different to that. But for autonomous systems to be viable for the future, they're competing with manned solutions that already exist. So there's a few challenges that need to be overcome. First of all, we need data now, it needs to be fast, ideally in real time. The endurance of the devices needs to be long-term, they need to be reliable, and in an ideal world, these would be low or zero carbon, reduce the cost, definitely reduce the risk to people's lives, which in turn enables us access to more remote, challenging environments without any compromise to the data collection. And something that's sort of not really mentioned is that it is an evolving field, so we do need to be able to adapt our solutions to be able to keep up with our clients' requirements. So when we talk about marine autonomy, there's sort of different platforms that we can work from. This is one of our ASVs, the Autonaut. There's loads of varieties out there, but likewise, this could be an aerial drone or even a satellite. There's numerous sensors that could be used. This is our thermal imaging camera, which I'll briefly touch upon later. But likewise, this could be PAM, it could be chemical sensors, eDNA potentially, or even things for communicating things already on the seafloor or deployed elsewhere. And the data collection could be recording raw data, such as WAV files and videos, or with AI, this could be have onboard processing and the like. When we're talking about levels of autonomy, there's three main levels. There's one of which is it's a sort of augmented autonomy where the humans doing most of the work and the autonomous is there to make it a bit easier for them. PAMGAR's a great example of this. Semi-autonomous, where decisions are made, but there's a human in the loop, and they're there to corroborate it to make sure everything's right. And then there's fully autonomous systems, which is the end goal, where something is reliable enough that it could be used for making decisions. All right, so a few case studies here. This is our smart visual detection system. It's a thermal imaging camera that's been around for a while, but more recently we're implementing AI onto it, as everyone is. So the driver for this was for mitigation environment and also with the US market in mind, preventing vessel strike. But likewise, it could be used for baseline surveys, and it doesn't necessarily have to be stuck on a boat. It could be stuck in a lighthouse and monitor a large area for a long time. I'll show a quick video of it in operation. And it's just broken on me. That's great. Okay, there we go. So, quick video in operation. This is it detecting a rather ambiguous whale. The classification will improve as time goes on. The more data that are collected, the more accurate this can be, ideally down to species level in the future. Next one, case study is our real-time sound measurement buoy. Driver for this was for monitoring pile driving globally, really, but it can be used for also monitoring continuous sound sources or ambient measurements. There's a demand in the US particularly for having reports to BOEM very fast so that they can make decisions and continue operations. But likewise, with the advent of the use of where are these breaking on me? Yeah, the use of things like noise mitigation technology is to make sure these things are working correctly and that thresholds are in place and these are not exceeded, so no one gets a slap on the wrist because they didn't know their bubble curtain wasn't working correctly. And final one, whistle through this, is the Autonaut. This is an autonomous vessel which is wave powered. Here it is being used in Barbados to work with the meteorological center and give early warnings for hurricanes, ideally saving lives. And a bit closer to home, here it is going out from Oban on a 115-day survey for beaked whales along Rockall Trough. This thing here is, it's a screwless system, which means it doesn't have a propeller, and in theory only needs to come in to have the barnacles washed off it. But we'll put this as an example, as it's our longest test to date, but hopefully it'll be out for a lot longer in the future. Any questions? Just email me and hopefully I can get back to you. Thank you very much.
Great. Thank you so much, Rob. Next, we have Prithvi Reddy from Thalm. And I don't believe I see Prithvi on our list, but I do see Jane. So perhaps, Jane, you'll be sharing, or I'll let you. Oh, there we go. Got it. Good. Go ahead.
Hi. So I'm Prithvi Reddy, and I'm a director at Thorm, a research and development lab based out of Canberra in Australia. We've been working with the AAD and NOPSEMA being the Australian Oil and Gas Regulator, to develop a solution to a challenge they proposed in 2022. What they asked for was a solution to detecting whales day and night in harsh marine environments for regulatory compliance. And we developed a solution called WhalePod. It's a turnkey whale detection and ranging system that uses a multispectral thermal and color camera system designed to detect whales at long ranges, but with high situational awareness. That means it can scan a 360 range in about 3 to 6 seconds, while still detecting whales up to the horizon in daytime and further than 3 kilometers during nighttime. We've been working on this product for a couple years now. We're currently in the middle of doing testing and bringing it to real world application. And we're looking for partners to help us take this to market. Please reach out if you'd like to talk more. And the design spec has been provided as part of the project, this presentation. Thank you.
Thanks so much, Prithvi. And I know it's quite late for you, so
Yeah,
we really appreciate your participation live here. So I'm going to move on, though, to Laura Williamson from BioConsult SH or HiDef. And Laura, I'll go ahead and leave it to you.
Hello, thank you. Yeah, so I'm a principal consultant at HiDef Aerial Surveying, and HiDef is owned by BioConsult. So I'm presenting our digital aerial surveying, which offers precise large-scale data collection that captures animals on the surface of the ocean. So we use this for marine mammals, birds, and then also any sharks, fish, jellyfish, etc. that are at the surface. So we use this for environmental monitoring and assessment for offshore wind farms, and we survey pre-post construction. We, HiDef, operate throughout the UK, Australia, and the US. And then our partner companies, BioConsult and Biotope, operate throughout Europe. Our bespoke camera rigs allow about 2 centimeter resolution and a 500 meter strip width. And we can capture up to 8 frames of an animal, which allows us to increase ID rates and behavioral assessment. And we also fly at or above 500 meters altitude to avoid any flushing of birds or influencing the behavior of target species. So I'll just show you, this is an image of Rizzo's dolphins in our imagery. So you can see this animal in the top right is at the surface, and the 2 bluer looking ones are submerged. We are also working on developing drones. So essentially applying our DAS survey cameras to drones. So this will allow the same coverage and resolution as our traditional crewed aircraft systems. However, it reduces health and safety risks as there's no people in the airport. And it also reduces carbon emissions and fuel efficiency. So this can be used for similar sorts of applications of environmental monitoring, impact assessment. And I think that probably is about my 2 minutes, so I will hand it over to the next speaker there.
Thanks so much, Laura. Really appreciate that. And we are moving directly on to, I believe, video from your colleague, Julie Voss from Space Whale. So I'll let Paige play that.
Hello, I would like to introduce BioConsult to you. At BioConsult, we conduct digital aerial surveys, which have already been presented recently by Laura Williamson from our sister company, HiDef Aerial Surveying. We are conducting passive acoustic monitoring, which has already been presented by Nick Tregenser, and we are using satellite imagery to survey wells in remote areas and thus to enhance conservation efforts. And this space well is what I would like to talk about. We all know that we live on a blue planet, and more than 80% of our oceans are still unexplored and unmapped. So little is known about them, even though we aim to protect 30% of our waters until 2030. And this is where space technology comes in, as with the space technology, we can fill the current knowledge gaps. And this is what we are making use of. So we are detecting waves from space using satellites, and this is what we offer as a service. In this way, we determine their number and distribution in large areas where it's too challenging for traditional survey methods. We use whales as indicators for high biodiversity and use these information for baseline studies, population assessments, and conservation efforts, helping evidence-based decision-making. Here you can also see a blue whale, how it looks from space. Usually when we see a blue whale from space, it rather looks like this image, for example, where you have the back of the blue whale above the water surface and the head of the whale below the water surface. We already applied space whale off the coast of 5 continents and validated our methodology. So we compared space whale results to an independent boat-based survey and observed similar numbers in southern right whales. We are combining state-of-the-art artificial intelligence and an expert quality assurance for verifying our results. And currently we are aiming to use space whale data for creating important marine mammal areas and creating marine protected areas. So the tools are in place to fill the current knowledge gaps, and we only need to apply them. This is our webpage where you can find further information, and thank you so much for your attention.
Thank you so much, Julika. All right, and our last speaker of this first part of session 1 is going to be Matt Dempsey from Dartmouth Ocean Technologies. And Matt, I'll give it to you.
There we go. Muted. Hey, everybody. Thank you so much for having me. Can you hear me clearly?
Yeah, we can. Thank you so much, Matt.
Okay. Thank you for the organizers for inviting us to be a part of this this webinar today. And thank you to Nathan from Nature Metrics for teeing this presentation up. He described the importance of eDNA better than I could ever hope to, I think. So my name is Matthew Dempsey. I'm business development at a company called Dartmouth Ocean Technologies. We're based in Dartmouth, Nova Scotia, Canada. Founded in 2018, we design and manufacture subsea nutrient sensors, depressor wings, and what I'm going to talk about today briefly, our eDNA sampler. Our eDNA sampler was developed in-house in 2021 by an in-house engineering team and with scientific guidance from shareholders Dr. Julie LaRoche and Dr. Rob Biko from Dalhousie University. The sampler works by filtering water in through a pump. So it's got one internal pump that pumps water in through filters. A keen eye will notice that those are actually Nature Metrics filters in the top slide there. But our sampler does some clever things along the way. It actually has reagent bags built into it that will preserve the sample that's collected. So we use RNA later, which can preserve the sample for up to a year. So the sampler, being fully autonomous, is able to preserve samples for up to a year at depth. The sampler has about 9 filters on the cassette, So you can take 9 samples before the sampler needs to be collected and then processed in the lab, such as Nature Metrics, for qPCR or full sequencing. The sampler also has a feature where it's actually self-clean and self-prime. So there's a compound on board that will actually flush out the system, eliminating the chances of cross-contamination between samples. The sampler, we've provided about 30 of these to industry thus far. You can see a list of our customers there on the bottom left quadrant of the slide. The advantages, Nathan went into quite a few advantages of eDNA, but it allows for non-acoustic detection of cetaceans and of marine species at large. So depending on how you test the samples, if you do qPCR on them, you can get a positive or a negative detection on a specific species you're looking for. If you go with metabarcoding or full sequencing on the sample, then it'll actually provide a printout of all the DNA signatures that were detected. So it provides a detection of marine invertebrates, of finfish and whatnot that might not be able to be detected through acoustics or other means. Next step in our development, we're working on a version 2.0 of our battery pack. We have a Slocum glider integration that's coming up. That's through a Scandinavian Research Institute partnered with an oil and gas or energy company. And we're actually probably most exciting working on an eDNA sampler, and that's the mess you can see on the bottom right quadrant, the wire spaghetti on a bench. That's going to do everything that a sampler can do, but it's also going to be able to treat the sample and process it with qPCR on board, providing real-time data output. Once the sample's taken, the qPCR has been run, it will actually provide you that information, the yes or no on the species detection over a RS-232 Ethernet, over Iridium, RF, you name it. So very excited about this next development. If you are all interested in some more information on our eDNA sampler, you can reach out to me in my email. That's there on the slide. I'll also post it in the comments as well. And I think I might be over time. Thank you all very much.
It's some really great information in there, though. So thank you, Matt. Okay, so let's go ahead and just take 1 or 2 questions verbally. We did have Erin Falcone, by the way, planned for Murray Cattell to present in this last part 1 session, but she's encountering some internet issues. So unfortunately, we won't be able to hear from her. I'm just going to verbally ask if anybody wants to raise their hand with any questions. We also have, again, a Q&A at the bottom, and there are a couple questions in there if folks would like to respond. And to those specific questions, I mean, there's one for Julika, and so if you have any general kind of responses, that'd be great. But I'll take 1 or 2, maybe verbally, if we have them.
Yes, I'd be interested to know for the eDNA on cetaceans, how long after the cetaceans went through a water body are they likely to be detectable?
Yeah, hi Nick. No, it's a great question and a common one we always get with eDNA. What is kind of the footprint? I mean, the first thing to take into account is it's eDNA, right? So it's not detecting the exact animal; it's detecting traces of DNA left over. But most research says it's a really pretty localized signal. Studying coastal ecosystems, they found different communities, over 100 meters. So it's not just when you detect it, depending on how you're detecting it. That signal dissipates pretty quickly, and most of the research shows it's on an hour to a day or two that DNA can last.
Thanks.
Thanks for that. And Nero, I see you're back here. Are we ready for our break then?
Yeah, I think we can take that to break then if there's other inputs.
Perfect. So those Q&As will stay open, so please do feel free to add questions as they come up and also respond. It'd be great way of being able to keep the conversation going. So we're going to take a break for 6 minutes until I've got 6:20 a.m. I think it's 15:20 your time or 16:20 your time. Sorry.
14:20 our time. We'll
14:20. I don't even know.
Multiple time zones for everyone. I appreciate the the confusion on everybody joining in at different time zones. But yeah, we'll meet back here in 5 to 6 minutes at 14:20 GMT. Thank you very much, everyone.
Okay, so we're gonna get back into things. Mackenzie, I see you have your hand raised. We'll hopefully have a couple minutes at the end of this second part that we'll be able to address that. So if you can hang tight to that question or throw it in the Q&A, that would be fabulous. And then also we've had quite a few emails here regarding the agenda. We did have to make some rearrangements just due to scheduling to accommodate everyone. So after we had sent out to the agenda, so there is a slight difference there, but we are working on that right now to get you access to the current agenda. And it looks like, Neera, if you can help out with that in the chat there, that'd be great.
We're going to see if we can share just the updated agenda just for everyone's information. We only moved people who wanted to be in an earlier time zone and would email directly the people who had been moved to a different slot. So it shouldn't affect anyone majorly. Let me see if I can just share my screen with this agenda.
Well, actually, it looks like there's that page has a link in the chat there. So we'll just go ahead and find a way of sharing a link to that for you so we can get going with our next set of presenters.
Thank you very much.
All right. So next we have Nick Tregenza from Chelonia, who will be presenting. And I believe, Nick, you have a video. So I'll let Paige go ahead and play that.
This talk is focused on larger scale acoustic monitoring of cetaceans with instruments from Chelonia Limited. Our experience goes back to the Samba project, which aimed to answer the question of whether the Baltic Sea harbour porpoise was extinct and how many were left. The automated classification that we developed achieved a false positive rate of less than 1 false positive second per year, and a large marine conservation zone has been created on the basis of this data, and a continuation project is now running. And a key point here, and it really applies to all monitoring methods, was that false positive rates must be very low, or positives occur everywhere, and animals can't go extinct. Here's just a quick glance at the distribution map for 1 month from that project. Another key project for us has been monitoring the trend in the vaquita in the Gulf of Mexico, a very acoustically hostile environment. Here, the low cost per detection of acoustic methods made high precision trend estimation possible even for a very small population, now down to 12 or less animals. In a much more cetacean-rich habitat, Marine Scotland have done spatially stratified sampling with sea pods over 10 years on the east coast, and this has been very useful. It's shown us the degree of spatial coherence of trends, which gives really useful evidence of how widely spaced an array of pods can be in a trend monitoring project. And it's been very encouraging for us in relation to the CAT project, Cetacean Acoustic Trend Tracking, which Chelonia is developing and providing the instruments for. The aim is to create a widely spaced low-cost array of FPODs to determine trends in the numbers and distribution of odontocetes, and to develop and evaluate cooperation with other projects, moorings of opportunity, the problems that arise, collateral benefits which have been substantial, citizen science, etc. So we want to get an array of pods around Britain that is maintainable on a long-term basis at low cost. There are some new methods that are just worth thinking about. Mark recapture of signature whistles of inshore bottlenose dolphins is showing promise. There have been a few papers on that. And some cetaceans have signature click trains. These are from narwhals in northwest Greenland, and we're participating in a project there. The instruments we're talking about here is the F-pod. There it is with an acoustic release, which can be used in locations with high biofouling rates and greatly reduces the costs of a project. The C-Sound is a new instrument which we're just about completing. It does 16 kilohertz sampling, 16-bit resolution for more than a year on one set of rechargeable batteries, and will have individually calibrated hydrophones. So we can sort of look at the strengths and weaknesses of these two approaches, the wave file recorder and the F-pod, and you can see that there is a sort of complementarity. And it looks like for a lot of projects, the best solution is to combine an F-pod with a wave file recorder, sampling at much lower sampling rates. In that table, I've put a question mark against odontocetes presence with wave file recorders because dolphin monitoring from wave files does still depend in all the publications I've seen on an experienced analyst checking the results, which is simply not a practical solution for the large-scale projects we're talking about here. Social click communication is a really exciting area. We're seeing amazing stuff going on there, but I'm about to run out of my 5 minutes, so thank you very much for your attention.
Thank you so much for that, Nick. And Nick is, I believe, is still online for questions later or in the Q&A if you have them. So next we have Christine Ward-Page from eOceans, and we have a video for that presentation as well.
Monitoring marine mammals to keep them safe and meet regulations is highly complex and slow. This is just one highlighting example where a lot of time and investment has been made. It shows a report on the progress of recovery for killer whales, published in 2022, but 3 years out of date. No matter where or what species you're working on, it's urgent and needs to be up to date to get the traction and decisions that are needed. eOceans was built to make this happen. Hi, I'm Dr. Christine Ward-Page, a marine and environmental scientist and the founder of eOceans. I spent 20 years collecting and analyzing data and generating reports for government, industry, academia, and NGOs, but we couldn't keep up with the change or challenges. That's because monitoring and research teams spend hundreds to thousands of hours collecting data and storing it all in different locations and formats. Then we process them for one question at a time, rewriting the same lines of code for each species in each location and for each data set. By the time our results come out, they're out of date and they never update. eOceans makes the process seamless, from data collection to reports and dissemination, unlocking up to 80% of your team's time and effort and delivering instant insights, where you add your data to the system and it automatically does what you need it to do. It's an elegant solution to a highly complex problem. And it works anywhere in the world for any species and their behaviors, health, as well as their threats, nearby developments, deaths, and social values, enabling you to keep up with all the challenges and opportunities. So how does it work? First, you'll set up a project in the eOceans platform. It's as easy as filling out a form. In the form, you'll define your study area, which includes a geofence that defines all the coordinates that you're interested in for your project. Then you define your variables of interest. This could be one species or all the species, as well as their threats and social values, and the types of analysis you want. It takes less than an hour. Then, once it's running, you add data. Data can come from uploading existing spreadsheets of data, sensors or APIs that are customized for your project, or through the eOceans mobile application, which is designed specifically for your field teams to collect data offline on the go in the field. Then, as the data are entered, they go to all the projects they need to go to. So this could be just one project or hundreds. It depends on your collaboration preferences and also on the data that you're collecting, such as the location, the sampling methodology, and the variables that were logged. This way, you can work seamlessly at local, regional, and even global scales. And for each project, all the data sets, maps, graphs, and reports are kept up to date in your dashboard with all your current data, allowing you to easily track your key metrics, such as sampling effort, species presence and absence, relative abundance, health, richness, biodiversity, threats, social values, and more. Now, your key performance indicators are never out of date. To summarize, eOceans has the functionality you need to make your data useful today. It's the equivalent of having $1 million team of data scientists working to deliver your project in a timely, efficient, and effective way so that you can focus on what matters most. It's important to note that eOceans has research-grade ethics at its core. We enable you to share your data, but we don't force it. This enables you to work with anyone, including First Nations, fisheries, tourism, and more. eOceans is a patent-pending process that was made in Canada by experts in quantitative ecology. And the return on investment for using eOceans depends on your current situation. And this falls into two buckets. First, if you already have a superstar data science team, then they can focus on the important tasks instead of the tedious ones. And if you don't have a data science team, or you are doing it all, eOceans adds the capacity of having a data science team to work with you. With eOceans, our goal is to help power your everyday projects, but also your most ambitious ones. You can learn more at eoceans.co or contact me for any questions or assistance to get your project up and running today. Thank you.
Great, thank you for that. Christine and Christina's online as well. So I've noticed too that folks are doing a fabulous job of answering questions. So keep populating that Q&A. Okay, so our last presentation in the second part of the first session is Zenaida Klestova from University of Tübingen. I'm going to say that incorrectly. I apologize, Zenaida, if you could correct me. And just to let you all know, after this presentation, we will likely be joining our breakout rooms, and I'll tell you about that momentarily. But go ahead, Zenaida. All right.
Listen me.
Yes, we can hear.
Okay, yeah. Hello, everybody. Good afternoon. My name is Zenaida Klestova. I am from the Institute of Medical Virology and Epidemiology of virus infections from Tübingen, from Germany. Modern threats to marine mammals' health and biodiversity depend on many factors, including climate and biological changes. Viruses are one such biological factor that is occupying new ecological niches, including in wild mammals. Some viruses are known to occur in marine mammals. We know some zoonotic viruses, as for example, as highly pathogenic influenza viruses.
Zenaida? Sorry to interrupt. We can't see your slides. I don't know if you want to share your presentation. There we go. Perfect.
Are you seeing it?
I can see your slides. It doesn't look like the first slides, but if you want to continue there, that's fine.
It's fine. Yeah, it's so slide. Yeah, now.
Great. Thank you,
And
Zenaida.
many zoonotic viruses spread in marine mammals. We know not only the highly pathogenic influenza virus, but herpes viruses, paramyxoviruses, rhabdoviruses, adenoviruses, caliciviruses, and which else? It may be others, for example, such as SARS-CoV-2 that spread due to its rapid mutation and adaptation to new species. Some sewage contaminants may play a role in viruses spreading that are common in coastal waters. This could pose a threat not only to marine animals, but also to a new wave of human diseases. On this slide, you can see some migrations, not only animal migrations, including marine mammals, birds, humans, but pathogens migrations. Examples of pathogen introduction routes into Alaska, as for example, in the left side in open upper the left side, you can see some routes of viruses such as SARS-CoV-2, highly pathogenic influenza viruses and other. And the second example spread the highly pathogenic influenza virus around the South America by mass mortality events in sea, in marine mammals. Our institute consists not only as from research departments, but we have many subdivisions in big diagnostic departments, and we used more than 100 new innovation methodologies to detect and investigate some emergent and re-emergent pathogenic viruses, and we have some space, especially space BSL-2 and BSL-3 for work with very dangerous pathogens. And we propose to our institute proposed to use our expertise and experience in the study of viral infections. For this reason, we propose some of our methodologies that can be used to monitor and isolate marine mammal viruses, to analyze the viral genomes, study phylogenetic relationships and epidemiology, identify new reservoirs and viral ecological niches, to collect viral isolates that can be used to characterize the relevant viruses and identify vulnerabilities in their replication cycle that can be used for prophylactic and therapeutic approaches. Thank you for your attention.
Thank you so much for that, Zenaida.
Sorry for some technical problem.
Oh, no. No problem at all. No problem at all.
Yeah.
It's really, really interesting work you all do as well.
And if you have any question, I can answer on it. Thank you.
Yeah. Yes, thank you. Just to let you all know, we have a 18-minute breakout room wherein we're going to be sending everybody automatically to one of 5 different rooms. The presenters or the marine mammal special interest group will be guiding us through a couple different questions, and then we return for the first part of session 2. So with that, I'm going to go ahead and ask that we be thrown in breakout rooms, and we'll carry on.
Okay, so we are now back into our second session. We're just a couple of minutes over. Thank you very much for everybody's participation there. It was really good to get so many comments in there. We're going to start our next round, and so we're going to run through here until 1650 GMT, so 4:50, and we're going to take a break in about half an hour's time. So first of all, we're going to now welcome back some speakers and some presentations. And we're going to start with Genevieve Davis from NOAA Fisheries. Genevieve, are you available to share your screen now?
Yes. Thank
Great.
you.
Thank you very much.
Okay. Thank you all for having me, and thank you for the introduction. I'm here to talk to you today about our Passive Acoustic Cetacean Map, which is an online application we've developed to explore acoustic detection data sets. And so this is just a map showing all of the passive acoustic data, or most of the passive acoustic data collected by our group and colleagues in the last 20 years off US and Canadian coasts. to just show the variety and breadth of how much data we have. And so what we wanted to do was to be able to explore all of the analyses that come from these data sets from different platforms. So we have both near real-time data sets as well as archival, bottom-mounted, and mobile. And so how do we utilize this data set in a way that we don't have to wait for all of these different publications to come together and to try and piece information separately? And so our solution was to create this site PACM, Passive Acoustic Citation Map. The current URL is up there at the top. What it was to allow exploration of all publicly available passive acoustic monitoring detections for both mysticetes and odontocetes. So for any species, from any platform, and from any data collection type, both archival and real-time and multi-platform. Right now, we have data contributions from all different types of organizations, so federal, state governments, industry, researchers, NGOs, and the idea is that anyone that has data can contribute to this as a whole. And we have this updated routinely so that we have the most recent archival detection data displayed. Soon this will be in near real time, so we'll be able to communicate with real-time platforms to be able to display as necessary. And again, the idea is that anyone that has detection data for any species can contribute using templates that we've created. And this is just an example of some of the templates. The idea is to be able to easily integrate your data so that we can then look at everything cohesively and in the same way. We have templates for detection data, metadata for all of the acoustic recordings and recorders, as well as GPS data for mobile platforms. Soon this will be something that you'll be able to upload yourself. So we're working on the 2.0 version of this, where you'll be able to manage your data on a database behind the scenes. That's coming. And for now, we have these templates to help you import your data as well as manage from there. Just to walk through quickly, if you do go to this URL, you're able to get a lot of information on the right by clicking About, User Guide, and Tour to help navigate and understand what you're looking at. You can filter through what species you want to look at, so which detections you're interested in. You can filter by the passive acoustic recorder platform type, filter by dates or seasons, years, and then the detection results. So whether you want to look at just detected species, possibly detected, or not detected or analyzed. There's a legend to show you what you're looking at, summarizing how many recording days you're viewing, as well as how many deployments are available. You can normalize by effort so that the circle size is corrected by how many days of analysis are available. And then you can also select a location of interest with a box, and it'll filter all of those other items accordingly. Once you find a location you're interested in, if you click on any of these recorder location points, a box of metadata will pop up to show you more information, as well as a time series showing you when and where there were detections and dates associated with that. So right now, this is used in the US as a national decision support tool by both researchers and managers, especially within industry. It's a great tool to be able to look and see in the past what we've gotten, as well as most recent detections. It provides long-term information on species, seasonal, and temporal acoustic occurrence. We require protocols and references to be submitted with the data set so that when you're looking at it, you understand, or we're able to know how that information was done. And it comes with citations so that if someone does use your data or looks at it, the contributors are attached to that data. We're working on, once this 2.0 platform comes out, we'll be able to have this as a requestable detections database so that folks can look and see what you're interested in, and then also request to use that data as needed. And there will be permissions allowed as you submit data, whether or not you want to be able to contribute to that detections database. And so this all came to us realizing we really needed a better, robust database behind the website for looking at everything. And so we created this McCara database with two primary goals. One is to make PAM data readily available to support timely research, management, and decision-making. So you can just go and grab all the information that's already been cleaned and organized. And then to make it easier to combine all of these different detection data sets and PAM data from different sources, different projects, to have it standardized and be centralized in one location. just to show quickly, there's a lot of different tables that make up this database so that it can fit your project and how your data is collected, and be able to capture all of the important elements in that, from the organization who collected the data down to the detections themselves. And we have templates for each parts of this in the database. And then just quickly, how do we go from the database to what you're viewing online in Packham? There will be spatial aggregation so that deployments will be grouped by site. So if you have a deployment that gets turned around every 5 months, you'll see it as one continuous stream. There'll be temporal aggregation, so sub-daily detections will be shown as daily presence and absence values on the map. And then there are several permissions to release the data to Packham. So you can utilize the database as a database yourself, and then you can specify on an analysis by analysis basis what data you want to be released to Packham to be viewed on the map, as well as what data sets you want released to be requestable so that you can contribute to that if you want. And then there's a quality control part of this so that as you submit data, there will be some quick checks to make sure it makes sense, like you don't have a recorder location on land, and dates are within the in-water dates, things like that, so that we can hopefully have some automatic checks before it goes forward. And so with that, that was a quick fly through, but thank you. Please feel free to ask any questions and get in touch. And it's a huge amount of people that have made this possible. So thanks to all the contributors and people involved.
Thank you very much, Genevieve. That was great. So we're now going to move on to our next speaker, Kate Indek from the University of New Brunswick. Kate, if you're available to share your screen now, please just jump in.
Hello everyone, I'm Kate Indek with the University of New Brunswick, and today I'm going to give a brief presentation on underwater acoustic gliders as monitoring assets for the dynamic management of shipping corridors to protect whales from vessel strikes. The Gulf of St. Lawrence, Canada recently became a foraging hotspot for the critically endangered North Atlantic right whale. Consequently, regional overlap of whale migratory movements with busy shipping lanes has contributed to an ongoing unusual mortality event for the species. To reduce the risk of vessel strikes to North Atlantic right whales, the Government of Canada developed a dynamic management action plan for shipping in the Gulf of St. Lawrence in 2018. Shipping lanes in the Laurentian Channel were divided into dynamic shipping zones A through E. In any given dynamic shipping zone, a mandatory 10-knot speed restriction for all vessels greater than 13 meters is triggered for a period of 15 days by one of 3 methods. A North Atlantic right whale is detected within a dynamic shipping zone boundary, either visually by an aerial surveillance platform, acoustically by a glider, or as a precaution when the dynamic shipping zone cannot be cleared by a surveillance asset during a given clearance period. All deployed Slocum gliders have a digital acoustic monitoring instrument that is equipped with a hydrophone and runs the low-frequency detection and classification system firmware, which automatically detects and classifies tonal sounds in real time. A subset of these detection data are sent ashore when the gliders surface approximately every 4 hours, which enables detected whale calls to be validated by an experienced acoustic analyst, and management measures to be triggered in response to confirmed detections. Across the 4 years being presented on here, we deployed 5 gliders, 1 each in 2020 to 2022 and 2 in 2023. This amounted to 580 days of acoustic surveillance by underwater glider, which spanned from mid-April to late September. Across these 5 deployments, we ended up with 32 detection days, or days on which right whale acoustic presence was confirmed by our acoustic analysts. Yearly totals were irrespective of deployment length. It is interesting to note that all detection days occurred between mid-July to mid-October, of which 2/3 occurred exclusively during the month of August. Alternatively, no definite detections were made during the spring months of mid-April to late June. In response to these definite detections, a total of 196 days of slowdowns were implemented between the dynamic shipping zones across years, represented here by the orange shading. One of the key takeaways includes the fact that interannual and seasonal variation in North Atlantic right whale acoustic occurrence in the dynamic shipping zones was not correlated with effort. This is due in part to their sporadic use of areas in proximity to the region's shipping lanes. Transitory overlap with the dynamic shipping zones can occur as whales migrate into and out of the Gulf of St. Lawrence in early spring and late fall, as well as when they travel from foraging grounds in the southern Gulf of St. Lawrence to those off the northwest tip of Anticosti Island. Additionally, gliders triggered proportionally more slowdowns per day as monitored in summer and fall, but not spring. North Atlantic right whales are facultative callers that produce upcalls less often in the spring than during other seasons in the Gulf of St. Lawrence. Traveling whales during migration are believed to call at lower rates and occur at lower densities than during other behavioral states across their ecological range. This lowers their probability of detection and may help explain why the gliders did not detect any whales until mid-July. However, this also indicates that there is potential for increased risk to North Atlantic right whales, particularly in June, when migratory and shipping corridors experience sustained overlap, but whale detection probability is reduced. And finally, although gliders are not a panacea technology, they are most effective when they are used complementary to other surveillance assets. They are a reliable, cost-effective method for the passive acoustic monitoring of cetaceans in remote areas. And any additional tool to the monitoring toolbox that we can add is necessary because ultimately what we want to avoid is any more of this. And with that, I would like to thank everybody for listening, and I am happy to take any questions about this project. Thank you.
Thank you very much, Kate. Our next speaker will be Ross Culloch from the APEM Group. Ross, please feel free to share your screen when you're ready. Thank you so much.
You need that should be me. Cheers. Thanks very much, folks. I think this one's definitely coming from a bit further back the road, if you like, from the technical readiness for us to be able to deploy this, if you like. So great to see what everybody's been producing and presenting so far. It's been really interesting stuff. So what I've got here is a chat about testing the efficacy of event-based sensors for seals underwater, actually. And Doug did a great job of kind of introducing part of this problem. And this is work that's largely been led by an ex-PhD student, Nick, based at Queen's Belfast. So this will be a little less down in the data like the other talks, I'm afraid. Here we go. So as Doug had kind of mentioned, where I'm based around this, if you like, is around tidal energy, which we've not chatted about too much. But one of the key issues, certainly around tidal energy converters, is collision risk. Again, it's not kind of alluded to, similar to birds with wind turbines. We have the same issue under the water, not just with marine mammals, but indeed with diving seabirds. And also thinking about animals passing through arrays, again, which Doug eloquently put forward with regards to some of the issues we have at kind of getting into that larger arrays of tidal devices. We really don't have them anywhere in the world at the moment. And largely the issue with that is thinking about how we tackle collision risk and how we quantify that. And it all kind of links into that key for licensing side of things as well. So again, great to see that so many people have kind of flagged this linking into policy side of things, because it really is what drives some of these technologies or developments on. So really the current visual solutions are the RGB cameras, standard cameras that we've heard a little bit about today, and these tend to be continuous recording, and where they've been used in that monitoring space, particularly in some UK-based projects, means that it's quite a costly process. It's all very manual based, and then again we're constrained in issues around light and turbidity. So for example, there have been conditions on licenses for operating demonstration tidal turbines, around only doing so during light, so you can actually monitor this. So there's a long story there for sure. That I won't go into before I wax lyrical on it. And again, actually, Doug mentioned the active sonar element of the work that he and Gordon and Carol and others have done at SMRU, which has been fantastic. But it links in again to some of the polls that you guys were showing at the start, which is these can be quite expensive bits of kit. And again, Doug did a great job of chatting about the PAM, showing the animals were going around it, telemetry tagging the seals. This is all really expensive stuff to be paying for. Sonar, telemetry tagging, people time. And all this is demonstrating that the animals are actually not coming in close proximity to the tidal turbine. So really what we're trying to do is look at solutions to try and tackle the near field and do collisions actually occur. So what we were looking at is this idea of event-based sensors, and these give a signal when a pixel detects a change in light intensity. So it's very much each pixel is independent of the next to generate that frame of an image. And we know that it works really well in a terrestrial environment. And really what I'm going to try and show here from next work is just how we've used this in a marine environment or in a classic environment. So Nick quite simply just set this up in the lab, looking to see how it would operate in low light levels and increased turbidity, and ultimately calculated a signal to noise ratio. And again, very simplistic. It was essentially a fan on the opposite side of an aquarium with water in it, where he changed the light level and the turbidity of the water by adding a solution. Really, what you find with that is the light levels decrease, the turbidity increase. Really down to these really low light levels and higher turbidity levels. So ultimately darkness, typical starlight. We were still getting signals. So essentially the camera was still picking up the movement of the fan through the aquarium. So this should just be a wee example. What we've got in Northern Ireland is there's actually a seal rehabilitation centre next door to the lab over in Portaferry off Brentford Loft where the work was done. And this is just an example of a seal getting fed. So on the right-hand side, you'll see the event-based camera versus a RGB camera, a GoPro. That's roughly the same footage. Obviously, it's a different camera, but you can hopefully see that the image of the seal in the event-based space. So yeah, the next steps. We've done a few camera drops with other collaborators. Some examples of some stills that we've picked up from this. And then one of the project partners is taking the kit out to Turkey, where he's deploying a demonstration tidal turbine to actually test a few more of the elements of understanding distances, field of view, etc. I think we'll have a few names there as well. So just to say thanks for listening, but really highlight that this is only one element of it. Azadeh and John over in Queens are from the IT department are really working at that machine learning element of actually pulling these images out and so on and so forth, and trying to automate those processes, as well as grabbing the video from the more ecology-driven side of the team, if you like. So very much in the space that everybody's chatting about automated processes, machine learning, AI. And that's all for me. Thanks.
Thank you very much, Ross. That was great. So our next speaker, before we take a break, is Calliope Nicopoulou from the University of St. Andrews. Poppy, if you're available to share your screen, please.
Hello, my name is Calliope Nicopoulou, and I'm a research fellow at the Sea Mammal Research Unit at the University of St. Andrews. Here with my colleagues Jamie McCauley, Doug Gillespie, and Peter Tajek, we are gonna present how that integrating of acoustic and movement tags to improve acoustic monitoring. There are different ways of surveying marine mammals, from visual surveys from boats or aerial surveys to passive acoustic monitoring, towed arrays behind the boat, or fixed acoustic receiver or autonomous vehicles. Regardless, the type of monitoring or the platform, we need to have a measure of effort, of our survey effort, and this usually is measured by the detection function or estimating a probability of detecting the species of interest around our monitoring system. And how the DTACs can assist us to estimate those parameters and how they can improve marine mammal surveys. So the DTACs are acoustic recording tags that they can be attached on the whales by suction cups. So they are not invasive and they can stay up on the whale for 2 to 3 days. They record high resolution movement data and also acoustic data. So that means that we know where the animals are producing sounds and also what was the acoustic environment while they were producing those sounds and what movements they were doing. So one type of data that we can extract from these tags are the depth profiles of the species and also where they produce sounds, either for foraging or communication. And like that, we can estimate the availability either for visual surveys or acoustic surveys. Also, we can see differences if there are differences between the same species but different populations, or we can see differences between the species, so we can have specific species-specific parameters. There are efforts as well to use DTAC data to estimate acoustic Q rates that they can be used then for density estimation, and one of such project was the Accurate project at the University of St Andrews with a collaboration with CRIM, SMRU and SMRU Consulting. Combining DTACs with field experiments, we can extract and estimate important parameters like the beam pattern, how the sound radiates away from the source, which is the animal. And one experiment like that was the estimate of a high-resolution 3D beam pattern of harbor porpoise by Macaulay and his colleagues. And also we can estimate detection function for larger species like the big whales in a specific location by combining again DTACs with drifting recorders. So we know the sound that they have produced by the whales as they have recorded on the DTACs, and then we can see what proportion of those sounds that they were produced we were able to detect and under what parameters. Also, we have created software to estimate detectability for different kind of parameters. For example, Macaulay and I have developed this type of software, which we use DTAC movement. We use DTAC data from DTAC deployments, and we are using the depth profiles, the orientation of the animals while they're producing the sounds, when they're producing the timing, when they produce sounds or not. We are using assumptions, of course, if we don't have information of specific acoustic characteristics like the beam pattern. And then we are able to estimate detectability for a different kind of parameters like the depth of the receiver or a combination of receivers. Outputs of this software can be detectability for specific parameters of our survey, for example, day or night, different habitats. We can see if there are any differences of behavior, like the work of Macaulay has shown, and also we can estimate, we can see as well if different assumptions that we are considering for acoustic production, like the beam pattern, can have an effect on our density estimates or survey parameters. Also, we can test the detectability between different assumed acoustic cues that we might fit one survey and not the other. And another application was that we were able to estimate, to use underwater gliders as platforms for density estimation by being able to estimate the detectability for a specific species based on the depth of the glider, because it has a lot extreme changes. So we see that the DTAC data and the DTAC deployments can assist in marine mammal monitoring by decision on acoustic cues, estimate detectability specific on PAM platforms, creating cost-effective experiments in the field, and increasing the accuracy of our estimates.
Thank you very much, Thank you very much for that. So we're now just going to take a quick break. We're a little bit running late just now, so we'll just drop that down to 5 minutes if possible. So if we could have everybody back here in 5 minutes, that would be great. Thank you so much. Hi, everyone. I'm sorry to cut the break a little bit shorter than our planned 10 minutes, but I'm sure everybody's more excited to get in with the next round of technology and methods that we can see in marine mammal science. So our next speaker is Kerry Seger. Kerry, would you like to talk live? I know you've sent a pre-recording as well. Just let me know.
Yeah, I'll go with live. We have power. It didn't get knocked out last night.
Great to have you back. Thanks, Kerry.
Yeah, thanks. All right, let me share my screen. Just about didn't do that. There we go. All right. Are you guys seeing it? Yeah. Okay. Good morning, everyone. Thanks to Liz and IMarEST for organizing the workshop. I'm Kerry Seger from Interval Consulting. I'm going to go through a few brief slides today to talk about how colleagues Kausar Kumar and Emily Barasin have used this vector sensing technology, the noise spotter, in the past to exemplify how it can be used for marine mammal monitoring in the future. So, progress slide, there we go. All right, so the noise spotter is a PAM device. It has 3 vector sensors alongside an acoustics pressure sensor. There we go. The pressure sensor can record up to 25 kilohertz, with the vector sensor recording up to 3 kilohertz. There is flow noise suppression that's part of the system. The noise spotter can also be telemetered to the surface optionally for sending data in near real time. Otherwise, it has onboard data. Stop slide. You do not need to go that fast. There we go. Otherwise, it has the onboard data storage that most of us are accustomed to for long-term PAM applications. The current version is at TRL 8 and can be deployed down to 200 meters, but there is a deeper rated version available, which I think is down to 1 kilometer. So how's this been used in the past? The first example for marine mammals is just figuring out the direction of our soundscape. Or of all the sources in our soundscape. So the top is the typical spectrogram from the acoustic pressure sensor that we're all accustomed to seeing, and the bottom is an ASIgram that the colors represent a little bit different information. So while the colorization is a bit similar, we interpret this as a bearing from true north. So if you look really closely, you can see that the ASIgram in the middle, there we go, come on. The teal color is 0 degrees or true north, and that humpback whale song, if you look at the shape from the spectrogram down into the ASIgram, it shows up pretty quickly as bright pink. So that's about 120 degrees or east to southeast of where the noise spotter is sitting. They also don't change much color over the course of the recording, so we can presume that the humpback whale is staying relatively still while he is singing. Also in the spectrogram, you can see these impulsive sounds running along the bottom, which are probably fish. And there's some of those faint horizontal lines that look like a boat. So if we switch to the ASIgram, we see those fish pulses are generally a bright blue or about 60 degrees or east-northeast of the noise spotter. And the boat engine is holding a pretty steady yellow or negative 120 degrees or a west-southwest direction. So this tells us not only what sources are present in our soundscape, but which directions they're all coming from. So we start to gain some spatial awareness of the ecosystem. And then the second application, which should be coming out under Emily's name in JASA EL soon, so be on the lookout for that, is directional masking. It's a slightly different color palette, but the same thing where we have the typical spectrogram on the top and the ASIgram in the middle. So in this case, the boat is in white and it's about true north from where the oil platform is sitting off to the northeast or in that burnt sienna shade. So by using directional masking, we can remove the sound pressure data that's associated with anything related to not the oil platform, which leaves behind that new spectrogram on the bottom That's just the sound pressure coming from the oil platform / the direction of the general northeast. So that excludes a decent amount of the boat noise, as well as anything in the din from other bearings around the noise spotter. And this can be repeated sequentially for all sound sources in the soundscape so that you can then measure the amount of received sound from each source separately. Therefore, we gain not only that spatial awareness of the sounds in our ecosystem that I had spoken about on the last slide, but we also get an idea of the relative intensity of those sounds, so we can begin to more precisely calculate things like noise budgets and track movements of the sources and how much sound each individual sound source is contributing to the soundscape in which direction. And that's all I have, slightly a little shorter than everyone else, so we'll get back on track. This QR code goes to my business card online, and I'd be happy to put anyone in touch with Kaus or Emily if you have particular questions about their work. Thank you.
Thank you very much, Kerry. Our next speaker will be Elsa Mullen, and we have a recording. Els had some power outage issues earlier. But she is joining on the call, so available to take questions, hopefully, if there's any at the later session. If we can play Elle's video, please.
Hello, everyone. My name is Els, and I'm the head of the MRI Whale Unit at the University of Pretoria. However, today I will be presenting here as a coordinator of the Southern Right Whale Consortium, which is an international collaborative initiative for research and conservation of the species. As the title indicates, this presentation is about the use of artificial intelligence to further our understanding of southern right whales. Right whales are distributed in the southern hemisphere in 12 main calving grounds, indicated here with a blue star. As the right whale to hunt, the species was hunted to near extinction in the early 1800s and knew an approximate 100-year bottleneck before it started to recover after international protection from whaling in 1935. So in this graph, you can see the historical reconstruct or population trajectories of the southern right whale pre-exploitation abundance, the decline, and then the recovery. This was published in Jackson et al. 2008. Following international protection of the species in 1935, southern right whales started to recover strongly in several places, especially in 4 calving grounds indicated here with the blue circles. These are located in the Southwest Atlantic, including Argentina and Brazil, in South Africa, Southwest Australia, and New Zealand. Several other populations remain at low numbers, including the Southeast Pacific in Chile, Peru, the Southwest Indian Ocean, and in Southeast Australia. To monitor the recovery of these population, research programs started several decades ago in the different calving grounds, mostly based on photographic mark recapture. Considering these whales are identifiable through their callosity patterns, photo ID surveys are usually aerial as to obtain the top-down images of the whales. These decadal studies have led to incredible catalog sizes in the different calving grounds, with over 5,000 individuals identified in Argentina, more than 1,000 of Brazil, over 3,000 in South Africa, 2,500 in Australia, and 600 in New Zealand. There are 2 main systems currently in place to process and match these photos, being the Hibby-Lovell system, mainly used in South America and South Africa, and Big Fish, hosted by ARPIC, the Australian Right Whale Identification Catalogue. Both these systems are semi-automated and require manual photo manipulation and annotation. And although it will provide a list of best matches, the confirmation of a match is still done manually and may take up to checking over 100 individuals each time. This means that these systems are extremely labor-intensive, with one aerial survey taking up to a month or 2 of dedicated time to process. Additionally, in case of the Hibby-Lovell system, it is a specific program that has not been updated since 2007 and therefore only runs on old operating systems, making it a risk of crashing or being lost. The current systems have been clearly led to an inability for right whale researchers to keep up with photo ID processing, especially now that the collection of photo ID data is ever increasing with the use of drones. Due to the large catalog sizes, it has also created the inability to consolidate regional catalogs, to conduct an inter-catalog matching, and to perform in-depth photo ID-based assessments like residency time, movement patterns, population connectivity, and global population dynamics. We thus clearly need help. Now, artificial intelligence and machine learning have long been used for photo ID, as can be seen in the platforms like Flukebook and Happy Whale, which I'm sure some of you are familiar with. However, the existing algorithms do not seem to work very well for right whales, and there is a need for an improved matching algorithm for the species. Therefore, the consortium has developed a project together with AT Design in Australia to pursue this option. As several algorithms are already available in the existing platforms, discussions are ongoing and algorithms shared in open source to ensure that the project doesn't start from scratch. Similarly, it is envisioned that the algorithm built under this project will be able to be used widely once finalized. To keep it simple, the project basically exists out of 3 phases. Phase 1 relates to the creation of a training dataset. This entails a standardized annotated right whale dataset for the development, training, and testing of several AI models. The datasets available for this are large, as you can see on the list. Therefore, the creation of such a training dataset itself entails a vast investment of time and skills. Phase 3 relates to the development of the matching algorithms that are specific to the species. This will be done by building on the existing algorithms like DeepSense and MUID from Flipbook. Phase 3 relates to the algorithm implementation and data integration, which basically entails the housing of the developed algorithm by building the user interface and the setup of the database structure. Obviously, application to other right whale species will then be possible as well. Today, we have sourced all funding needed to proceed with Phase 1 and 2, and we are very grateful to the following partners. As it stands, we're in the process of sourcing the needed funds for Phase 3, so that we can finalize this project sooner rather than later. Thank you very much.
Thank you very much, Els. Our next speaker will be Alexander Sutton from the Stevens Institute of Technology.
Present brief information about Stevens Passive Acoustic Detection System SPADES that we developed at Stevens Institute of Technology that is located on the bank of the Hudson River. We have built many directional arrays, and this is a system we developed mainly for border security and port protection, and our best system is SPADES 2, which is 8 gigaphones. Early SPADES version has 3 gigaphones, and this system was used for 10 years. Also, we built directional recorder and smart acoustic buoy. We tested a lot of different targets using our systems. Our test started from divers, and we detected UAVs and small boats. We collected very large library of acoustical signatures of different ships, and some pictures of these ships are presented here. Advantages of our system for marine mammal detection and localization are connected to this very high directivity of the system that can provide target localization. Also, detection distances of our system are much longer than for single hydrophone systems. Stevens Institute of Technology has 3 SPADES units in storage, and we are interested in this system's application for marine mammal detection. Thank you for your time and attention.
Thank you very much, Alexander. We're going to move now on to Francois Gauthier. If you're from Devotion, if you're able to share your screen, Francois. Thank you.
Yeah, can you see it?
Yep, that's great. Thank you. Loud and clear as well.
Great, thank you. So, hello everyone. My name is François, and I'm here to represent Devotion. At Devotion, we are leading the future of sustainable fishing with our ropeless fishing system. It's designed to protect marine life, especially whales, while still optimizing for operation for fisher. Our solution consists of 3 key tools. The first one is a submersible buoy that stay on the seafloor, removing any intermittent risk. The second one is our client app that sends an acoustic signal to release the buoy on demand. The last one is a rewinder system that ensures seamless rope management on deck. The system not only supports fishing industry, but also paved the way for a new era of acoustic monitoring and underwater data collection. Indeed, we are integrating an acoustic monitoring system. It's going to be powered by AI. It will be implemented on the boat, helping reduce vessel strikes. It will also be implemented on the buoy, which is going to massively improve our capacity to monitor whale movement, since it's going to be implemented directly on fishing gear a bit everywhere on the Gulf. Our technology will also enable environmental data collection to improve our understanding of the ocean and strengthen the conservation effort. We are developing the technology to easily add or remove specific sensors, such as temperature, depth, pressure, depending on the use case and client need. At Devotion, we believe that innovation and sustainability can go end to end. We are looking for collaborators, researchers, industry partners to push the boundaries together. You can reach us at the email shown on the slide, or you can always take a peek on our website. That's pretty much it. Thank you, everyone.
Thank you very much, Francois. Next, we have Cormac Booth from Mammal Research Unit Consulting, SMRU Consulting, and we have a recording for that. Thank you very much.
Hi, everyone. My name is Cormac Booth. I'm the Scientific Director for SMRU Consulting, based at the University of St Andrews. And just want to introduce you to the company and the kinds of things we do. So we're a wholly owned subsidiary of the University of St Andrews. We were established back in 2006, so just under 20 years old now. We've got operational offices in the United Kingdom, Canada, and the US, with 23 full-time science and engineering staff. In terms of the kinds of work that we do, a lot of that is in collaboration with the Mammal Research Unit and CREAM at the University of St Andrews, but more and more focusing on offshore wind in recent years, now supporting over 36 gigawatts of offshore wind projects to date. Also a lot of work in ports and infrastructure and defence contracts. And typically our role is bridging that gap between research, industry and regulators, and that's somewhere we've been pretty successful in recent years. In terms of the kinds of services that we provide and the technology that we've developed and utilize, we kind of group it into science and into technology. So on the science side, a lot of our work is on the permitting and consenting side of things, in offshore wind, ports and infrastructure, and supporting compliance on defense applications with the US Navy primarily. And then strategic research, a lot of modeling, trying to find and develop innovative solutions. So developing new products to support our clients with their compliance needs or in their research needs. A good example of that is the interim PCOD model and new versions that will be coming out soon in 2025. And then also increasingly using tools like aerial photogrammetry from drones. In terms of kind of other pure technology tools, if you like, we have a series of products, part of the Coastal Acoustic Buoy family or CAB family, primarily geared at short-term monitoring and then perhaps better suited for mitigation operations. And these are systems that provide real-time and archival cetacean detection and localization, noise monitoring, and also have applications in sound field verification. So that's really just a very quick summary of the kinds of work that we do, and please get in touch if you have any questions.
Thank you very much, Cormac. Just a reminder for everyone, we'd love to get your further engagement as well. So please feel free to use the Q&A feature. We're getting some great questions coming in there, but keep them coming. Our next speaker is Pina Gruden. We're also going to try and squeeze in Erin Falcone, who sadly had missed the earlier slot due to some storms. Hopefully Erin's able to join us after Pina before we wrap up. Pina, please share your screen and go ahead. Thank you so much.
Thank you. Can you see the screen?
Yes, all good.
Okay. Hi, everyone. Thank you for having me. My name is Pina Gruden, and I will briefly showcase my work with marine mammal tracking using passive acoustics. Passive acoustic monitoring is crucial for studying marine mammal populations. However, the challenges we face are significant. There are vast amounts of collected data, high noise levels, multiple overlapping sources, and often a need to integrate data from multiple sensors to achieve meaningful results. I develop advanced algorithms capable of tracking multiple concurrent acoustic sources in challenging conditions, even with false alarms and misdetections present. Unlike traditional manual analysis, my automated methods efficiently process large data sets while providing objective, repeatable results. These methods have proven successful across diverse tracking scenarios, from extracting frequency content of dolphin whistles using single hydrophones to spatial tracking with various array configurations. For example, linear arrays, wide baseline stationary arrays, and also acoustic vector sensor arrays. The figure on the right shows an example of 4 sperm whales tracked simultaneously using bottom-mounted wide baseline arrays. This is part of my latest research work in collaboration with the University of Hawaii and Naval Information Warfare Center Pacific under an ONR grant, and is also under review in Nature Scientific Reports. The output of such automated tracking methods advances our ability to monitor marine mammal distribution, abundance, and behavior, providing valuable information for mitigation, conservation, and management efforts. For more information, please visit my website via the QR code provided below, or send me an email. Thank you.
Thank you very much, Pina. Erin, if you're available, are you able to share your screen and join us?
I hope so. Let's give it a try.
Great to have you. Thank you so much. Thanks.
No, I'm glad I was able to make it. Let's see. Got it?
Not yet.
Oops. Sorry about that.
There we go now. Thank you so much.
Okay. So my name is Erin Falcone, and I'm a biologist with Marine Ecology and Telemetry Research, MarEcoTel for short. We're a small 501c3 nonprofit. We're based in Western Washington State in the US. So if you see the map, the little star at the top corner. But I'm going to talk briefly about a large project that we've had going on for many years at the Southwestern United States. Our mission is essentially to conduct research pretty broadly that supports conservation. And we also do a lot of technology development to help kind of support our research and other research needs for problems that are otherwise a little bit difficult to address. And this project is a good example of that. So where we're looking at is the Southern California Tactical Training Range. It's based off of San Diego, and it's a really, really broad area of the ocean that centers on San Clemente Island, where there's all sorts of military training going on, but in particular, a lot of anti-submarine warfare. The study site's difficult to get to. The weather can be really prohibitive. Logistics are always a challenge. We're trying to work in a really busy range where they, do everything from sonar to Tomahawk missile firings and things. And the key species of concern are pretty inaccessible species. So this includes beaked whales because of their sonar sensitivity, and fin whales, which are an ESA listed species and not very well understood, especially in these outer waters of California. So our approach is kind of the Swiss Army knife of research. We tend to work out of small vessels. So we're looking at like 25-foot ribs, and we pack as many research tools into that boat as we can to really maximize the data we can collect in the limited time we have in our study area. So we use photo ID, and that contributes to population structure, abundance, and survival estimates. We do a lot of tagging, which lets us collect behavioral data, such as critical habitat, foraging rates, and then the impacts on an individual level of training. We use aerial photogrammetry, primarily looking at health, both of individuals and then also across populations, and biopsy sampling, which gives us more data on population structure and health. We share these data really broadly, so we have a lot of collaborative analyses in addition to analyzing and publishing our own data products. Pretty much that's how we feed back into the management framework that helps the Navy monitor and ideally mitigate some of the impacts of their work. And that's it. Thank you.
Thanks very much, Erin. Okay, so fantastic lineup of speakers and great topics. We're now going to move into our second breakout session. So again, from all our participants, we're going to be automatically allocated into 5 different breakout rooms. So please feel free to use this time to get acquainted with your fellow breakout room participants, and feel free to speak freely and put your points across. A lot of us know each other, so let's not be shy. Thanks very much, everyone. Thanks, everyone. Appreciate the breakout rooms. We had some technical troubles there on a couple.
Sorry, I was talking to myself there for about 3 minutes.
It was all very valuable, I'm sure there is. Thank you so much. Yeah, so thanks everyone for your participation today. We are going to just use the next few minutes to wrap up. But we will try and take some questions. Liz, would you like to lead on that side? And then we can do a close up and summary. Thanks.
Yeah, and to be honest, I think maybe if there are any kind of overarching questions that anybody has, please feel free to raise your hand. But I'd like to just address the last couple otherwise that are on our Q&A. So just pause for a moment in case anybody has something.
And if any of us want to show the camera as well, just to put your cams on before we close up, it'd be great to see everyone's faces if they'd like to join.
All right. Not saying hands, and I'm not hearing unmutedness. That's all right. So one of the two questions that we had in the Q&A was, could you share any management applications of IPCOD without the DEB models? So I don't know if we have anyone on who could address that. Cormac, I believe, maybe.
I don't think Cormac's on.
Yeah.
But from the point of view of running environmental impact assessments that we would do quite regularly for offshore wind, as with Cormac's team, they do feed into those processes and are pretty much always requested by the regulator as a way of quantifying disturbance to the marine mammal populations that IPCOD allow you to analyse. Yeah, a few others maybe saying the same thing. So yeah.
Thank you very much, Ross.
I might be able to speak to that too also, Liz. Like a lot of the work that we do for the Navy deals with these very long-term sort of cryptic population effects. So a lot of our data feeds into that PCOD framework. So it's really more built to address not sort of a short-term acute effect project, but more we have chronic exposure, particularly in a case where it's not going to be directly easy to measure or quantify by other methods.
Great. Thank you, Erin. Anybody else? All right, then I'm just going to, which is for Laura, and she had asked how far offshore and for how long do your systems fly?
I assume that's for the other Laura from APEM.
Maybe, yes, I believe so.
Fly similar surveys.
Yeah.
I mean, it's a small airplane, so it can go out and we survey an entire wind farm. If it's a really big area, we might need 2 or 3 planes flying to cover the area within a day.
Great. Thank you very much for that. All right, so I think, again, there's maybe one or two questions that folks can just take a look and see if they have an answer for. And other than that, I think, Nero, we're ready to, thank you. I think we agree with you as well. All right.
Thank you so much, everyone. I appreciate, we're at the end of the day and many have other responsibilities to nip off to. So I'd just like to extend a huge thank you from the team at IMarEST and Defra. We really appreciate everybody's participation here. We had a great interest here. Thanks to all who participated in our survey. We had over 133 respondents. We had over 300 people registered today, although I think we had about 150 who were in attendance. It's fantastic to see. We have a really great community in the marine mammal science sector. And it's great to see so many familiar faces as well. And building these relationships and collaborative approaches like this is how we move forward. So thank you so much. Just a couple of notes. We will be finalizing our report, which will be completed next month for Defra. Once it is published, we will try and update you all with regards to a link that you'll be able to access that as well. There'll be a summary within the report of the workshop findings, and horizon scanning and our literature review, etc. Again, we might have some further outputs from it, but we'll just keep you waiting on those as well. Just a little note as well. Many of you who participated were also offered the opportunity to provide some information or some spec sheets. We'd sent those in an email. Many have collaborated and submitted spec sheets. They're not part of this workshop, but they're just shared with Defra as well for their reference as well. So it was just a set of slides. If anybody's interested in sharing any of their products or services or anything like that, please feel free to reach out to us on the emails that you have with regards to the organization of this event, to Liz or myself or anyone else on the team who you've networked with. It'd be great to hear from you. And again, just thank you so much. If I've missed anything there, Liz, just let me know. But we can just close the event now. And thank you so much for everyone.
Thank you very much.
Thanks to all our team as well, Lorenzo, Ashley, Ash, Andrew, and Liz, and also our colleagues on the Defra and IMarEST technical team as well. And thanks to Paige for curating all behind the scenes here. It's a big job there. But yeah, thank you so much.